A warm welcome to today's math class. Look at the question for us here. It's another simple one. The question is the square root of k plus the square root of minus k equal to 4. What is the value of k that will satisfy this equation? Easy, right? So let's take this step by step. First thing, solution. All right. Now look at the expression we have here now. Again, we want to move this to this side of the equation. Okay? So if we move this to this side, we're going to have here to be square root of k. This is equal to 4 there minus the square root of minus k. All right. We want to eliminate this radical. So we square both sides of the equation. So this square, this square. So what happened? This power goes with this radical. So we have here k will now be equal to. Now let's take time to factorize or simplify these gradually. This is written as this multiply itself. So minus the square root of minus k. All right. So we can use this bracket to open up this bracket, right? So this is equal to 4 times 4 will give us 16. 4 times minus k will give us here minus 4 root minus k. Then we come to this term minus root minus k. Then times 4 will give us minus 4 into square root of minus k. Then minus root minus k times minus square root of minus k will give us here plus our square root of minus k all to the power of 2. All right, so we have this to be 16. Then this will give us minus 8 into the square root of minus k. Then plus this power goes with this radical. So we're going to have here minus k left here. Again, this will now give us here 16 minus 8 root minus k minus our k, because plus times minus will give us minus. Now again, remember we have our k down here. So we have our k is equal to this. So if we have this, then look at this. We want to move the whole of this expression to this side and take this k to this side. So this is going to give us our 8 then into the square root of minus k. This is equal to our 16 minus k. This crosses to this side gives us minus k. So we now have 8 into the square root of minus k equal to 16 minus 2k. Easy, right? I know this is a very simple one. Now, this is divisible by 2, divisible by 2, divisible by 2. So let's divide through by 2. So if we divide through by 2, then this will give us this. So 2 here we have here 4, 2 here we have 8, 2 here 1, 2 here 1. So this ends up giving up our 4 into the square root of minus k. This is equal to 8, then minus our k. Easy. Again, this is a radical we must eliminate in the system. So from here, let's take the square of both sides. We can take the square of this other side. Let's continue here. So from here, we can work on this now to give us, but before that, we still have some space here. Let's make use of this space. So we're going to have here 4 times 4 itself times, we're going to have here root minus k times root minus k. This is equal to, this is written as 8 minus k bracket 8 minus k. All right, so we use this to times itself. So this expression is affecting this is affecting this. That's what I've written out here now, right? So from here, 4 times 4 will give us 16. So this gives us 16. Then this and this will leave the system. Going to give us here into minus k close bracket equal to, then here we're going to use 8 times 8 will give us 64. So we'll have here 64, right? Then 8 times minus k will give us minus 8k. Then we have our minus k times 8 will give us minus k. Then our minus k times minus k will give us plus k to the power of 2. Is that part still visible? So sorry about that. You can see every part now, right? Good. So from here, we can use this to multiply this to give us minus 16k. This is equal to our 64. Then minus 8k will give us minus our 16k plus our k to the power of 2. Right? Good. So we can move this to this side because it has its own brother. Or better still, let's move this quantity to this side of the board so that here turns to 0. So we now have 0 equal to 64, then minus 16k. This comes to this side, turns to plus 16k, then plus our k to the power of 2. So this leaves the system. And so we are left with our 0 equal to 64 there plus our k to the power of 2. Easy. Well, so we can rearrange this now. Or better still, let's move this to this side because it is k we are looking for. So this is going to give us our k to the power of 2. This is equal to minus 64. I believe there's no confusion here. What I did here, I moved this to this side to take a place of minus while this remains this way. So because we are looking for this, I have to move this to this side and bring this to this side to give us this. So what are we looking for? We are looking for k, right? So we take the square root of both sides of the equation. So from here, we take the square root of this side and we take the square root of this side. And at that point, we introduce our plus minus. So we have our k, because this leaves the system, is equal to plus minus. Here, this expression we have here could be written as minus 1 times 64. And according to the law of sword, we can separate this. The law which says that if you have your root a, b, that's root a times b, this is the same thing as root a times root b. So we can separate this. So if we do that, this is going to give us our k is equal to plus minus the square root of minus 1 times the square root of 64. Let's put this in bracket. All right. Now, this is a perfect square, which is 8, right? The square root of 64 is 8. So we're going to have this to be plus minus. And what is the square root of iota? We know that the square root of, square root of minus 1 is equal to our iota. So with this, we can bring that in here. So this is going to give us our iota times our 8. Yeah. Okay, so in all, we now have here, therefore, our k is equal to plus minus 8 iota. So we now have k1 is equal to 8 iota, and our k2 is equal to minus 8 iota. So these are the two roots that satisfy the original equation here. A very simple one at that. All right. So this brings us to the end of this smart class. Thanks for being there. Thanks for watching Online Maths TV all the time. We love you and keep watching Online Maths TV. Until we see you in our next video, keep winning. Bye for the now.